Hello everyone, welcome back to Algorithm with Chelsea. Today we will practice for loops with lists. Let's begin. Here are today's goals. First, compute the sum of a list using an accumulator. Second, find the maximum using a current best value. Third, filter even numbers into a new list. Fourth, reverse a list by looping backward. Before we do the for patterns, let's quickly review list traversal. Traverse means we visit each item one by one. Look at the list name numbers. It has 3 items, 3, 1, 4. The loop says, for x in numbers. That means x becomes each item in the list, one at a time. Inside the loop, we print x, and that print line must be indented. Indentation tells Python this code is inside the loop, so it runs once per item. Question 1. List traversal. We have a list named colors, red, blue, green. The loop prints C, and C becomes each color one by one. What is the output? Pause and answer. Let's check. The output prints each color on its own line, because print runs once for each item. First red, then blue, then green. Now that we can traverse a list, we can start doing useful work inside the loop. Now let's compute a sum. We use an accumulator, which means a running total. We start with total equals 0. Then for each number x, we update total to be total plus x. At the end, total is the sum of the whole list. Let's walk through the code. Numbers is a list, 2, 5, 1, 4. We set total to 0 before the loop starts, because we have not added anything yet. Then the loop visits each x in numbers, from left to right. Each time, we do total equals total plus x, which means add x into the running total. So total becomes 2, then 7, then 8, then 12. After the loop finishes, we print total. Question 2. Fill in the blanks to compute the sum of 3, 6, 2. Make sure total starts at 0, and x comes from the list numbers. Then predict what print will show. Pause and answer. Let's check. We start with total equals 0. Then we add 3, add 6, and add 2. The final total is 11, so the output is 11. We have learned the sum pattern. Keep a running total. Now let's learn finding max in a list. This story of elephant and corn will help with understanding. Imagine an elephant walking across a cornfield. Each corn has a length. The elephant can carry only one corn with his trunk. He wants to take home the longest corn. How can the elephant be sure he keeps the longest corn? He picks the first corn as his current best. Then, each time he sees a new corn, he compares it with what he carries. If the new one is longer, he drops the old one and picks up the new one. In this way, he is always carrying the longest corn that he has seen so far. In the end, he will carry home the longest corn. Now we turn the story into Python code. Corns is the list of lengths, 7, 2, 9, 4. Current max means the best length so far, the corn the elephant is carrying. We start with the first item, corns at index 0, which is 7. Then we loop for x in corns. X is the new corn we are checking. If x is greater than current max, that means we found a longer corn, so we update current max to x. At the end, we print current max, which should be the longest corn in the whole list. To really understand it, we will trace the loop step by step. The corns are 7, 2, 9, 4. At the start, current max is 7, because we picked the first corn. Now x is 7, the first corn in the loop. Compare 7 with current max 7. 7 is not greater than 7, so nothing changes. After checking the first corn, current max is still 7. Now x is 2. Compare 2 with current max 7. 2 is not greater, so current max stays 7. Now x is 9. Compare 9 with current max 7. 9 is greater. We should update current max from 7 to 9. The last x is 4. Compare 4 with current max 9. 4 is not greater, so current max stays 9. The final output is 9. The elephant will take home the longest corn, which has a length of 9. Now we switch from the story back to the normal math problem. Find max of an integer list. Now let's say it in math words. We have a list called numbers containing 7294. Our goal is to find the max, which is 9 in this example. This is the same as the elephant and corn story. List numbers records the corn lengths. The elephant wants to carry home the longest corn, which is the max number. Here is the idea. Use a variable m to store the max so far, like the elephant's carried corn. Start with the first item. M equals numbers at index 0. It's like picking the first corn the elephant saw. Traverse the list, just like the elephant walking through the cornfield. If an item x is greater than m, we update m to x. It's like dropping the old corn and pick up the new corn. Let's read the code. Numbers is a list containing 7294. We set m to the first item, so we have a starting best. Then, for each x, we check, is x greater than m? If yes, that means x is the new best, so set m to x. Finally, m is the max of the list. We print m. Let's check the output. The maximum number is 9, so the output is 9. Question 3. Find the max number. Numbers is 5183. Fill in the blanks in the if statement, so we update m only when we find a bigger number. Then predict the output. Pause and answer. Let's check. We loop through the list and keep the current best in m. If x is greater than m, x is the new current best, and we set m to x. The largest number in the list is 8, so the output is 8. We have computed sum and max of a list. Next, select even numbers into a new list. We have a list 1, 2, 3, 4, 5, 6. We want a new list that keeps only the even numbers 2, 4, 6. Here is the idea. We start with an empty list named evens. Then we traverse the input list numbers and decide if each list item is even. X is a list item. X is even if x modulo 2 is equal to 0. If x is even, we append it to the evens list. Append means add it to the end of the list. Here is the Python code. In the code, numbers is the input list. Evens is a new list for storing the even numbers. It starts as an empty list. For each x in numbers, we test if x modulo 2 is equal to 0. If yes, we know x is an even number, so we append x to the end of the new list. At the end, we print evens to see what we collected. Let's check. The even numbers are 2, 4, 6. So the printed list is 2, 4, 6. Question 4. Pick odds. Numbers is a list of 10, 11, 12, 13. Odds is a new list starting empty. Traverse the input list numbers. If list item x modulo 2 is equal to 1, we know x is odd and append x into list odds. Print odds in the end. What is the output? Pause and answer. Let's check. 11 and 13 are odd, so the output is a list of 11 and 13. You have learned how to filter even or odd numbers. Now let's study how to print a list in reverse order. In this example, we are given a list named colors. It contains strings, red, green, blue. The goal is to print items from back to front. The expected output is blue, then green, then red. Here is the idea. To go backward, we loop over indexes from the last index down to 0. Let n be the length of colors. Here, n is 3. In range, the 3 arguments are start, stop, and step. The start is n-1, so the start is 2. The stop is -1. The range will stop before -1. -1 is not included. The step is also -1, which means counting down. Thus, the range gives indexes 2, 1, 0. Finally, we print colors at index I each time. Let's turn the idea into Python code. Colors is the input list containing red, green, blue. We set n to the length of colors. Then the for loop uses range starting at n-1, stopping at -1, step -1. Range stops before the stop value, so it will stop before -1, and the last index it uses is 0. That produces 2, 1, 0. Each time, we print colors at index I. Let's check the output. It prints blue, then green, then red, each on its own line. Printing backward is useful, but sometimes we want a new reversed list we can save. In the Python code, students is the input list containing Alice, Bob, Chelsea, David. REV is the new list for storing the reversed item. It starts empty. Let n be the length of the list. We loop I from 3 down to 0. Inside the loop, each time we append an item at index I into rev. Finally, print list REV. Let's check the output. The new list, REV, becomes David, Chelsea, Bob, Alice. So the output is a list with those names in that order. Let's summarize what we learned today. First, list traversal. For item in list means item becomes each element, one by one. Second, compute sum with an accumulator, total. In each iteration, add total and x, and then assign the sum back to total. Third, find max. We keep a current best, m, and update m if an item x is greater than m. Fourth, filter even numbers into a new list, using append. Finally, reverse by looping indexes from the last index down to 0. This concludes our lecture. Thank you for watching. Please subscribe to Algorithm with Chelsea so you won't miss future updates.